Number 33. Identical blocks A and B are being pulled by force sensors across a rough horizontal surface. The force Fa exerted on block A and the force Fb exerted on block B as functions of time t are shown on the graph. Which of the following could show the correct graphs for the accelerations AA and AB as a function of time for the two blocks? Well, you have either one of two possibilities here. Either the two forces make the objects move at constant speed, in which case this force, which is more or less constant, is countered by a similar friction force in the opposite direction, and the same is true for this force. Now, in that case, you will have an acceleration of 0 for the two objects, which is neither of the cases here. Therefore, we must assume that this force is greater than the force exerted by friction, and given that the two blocks are identical and therefore have the same mass, we must assume that they are going to accelerate due to the different values of the forces. Now, from Newton's second law, we know that the acceleration is equal to the net force, in this case either Fa or Fb, divided by the mass. We have then a constant acceleration because the net force is going to be constant. Now, Fa is significantly lower than Fb, which means that AA has to be significantly lower than AB, and that is option E, constant accelerations with acceleration for block A lower than acceleration for block B.